All right, so this is Unit 4, Formative 1, Video 1, Rate of Change. Another way to say rate of change is we call it slope, okay, which is the rise over the run of a line. Okay, so let's look at one. So here, this is an example. Rate of change, again, remember, is just another way to say slope. Okay, and the rate of change is going to be how much something rises over how much it runs. Okay, so this one would have a rate of change of 6 miles for every 1 hour. Okay, so if they were riding a bike, okay, and they were on their bike for an hour, they would ride 6 miles. If they were on their bike for 2 hours, they would ride 12 miles. So it's a rate of change, it's a ratio. Okay, so now here, we're going to find the rate of change. Now, something you need to be careful about is whenever you have a table and it has units, you need to use your units when you give the rate of change. Okay, so now this one has 3 points. We only need 2 points. Okay, so on this one, what we have to do is we need to figure out how much it's going to rise over how much it's going to run. So I picked the 2 farthest points, but you can pick the 2 closest ones. I'll show you what happens when that happens. So we have the slope, or the rate of change, is the rise over the run. Okay. So our rise is how much it's rising, and it's 2 units. Okay. However, we have 2 units, but each unit's 80. Okay, so this is 80 and this is 80. So the rise is actually 160 miles. You have to be careful when you have units, okay? Now our run, okay, is going to be left to right, okay? Now these units, we went 2 units. However, each unit goes up by 2. So this would be 2 and 2, so it gives us 4 hours. Okay, so our run is 4 hours. Now, something you have to do with whenever you're doing rate of change is you have to make sure to simplify. So I'm going to take this and simplify 160 over 4. 4 will go into both of those, and it would end up being 40 miles for 1 hour. Okay, you need to make sure you use your units, and when we're talking about rate of change, I know that we don't have to have a 1 here in a fraction, but when we're talking about rate of change, it is always rise over run. So we like to keep that in a fraction, okay, because we have to show how far it ran. Okay, so on this one, we're going to find rate of change, and you can see there's several different lines. We have A, B, C, D, E, and they all have a different rate of change and different steepnesses to the line. So we're going to go ahead and find the rate of change for line A, so which is this line here. Now, a couple things you need to remember whenever you're looking for rate of change is you need to make sure you got to pick 2 points, okay? And when you pick those points, they have to be in exact locations, okay? So for example, I can pick this point here because it's at a grid mark. I don't have to guess where it's at. And I can pick this point here. What I can't do is pick here, okay? Because I don't know how far up and how far over I would be guessing. Okay, so you always want to make sure you pick exact locations, okay? So what from here, I'm going to draw my rise and my run lines, okay? So my rise is 2 units. However, each unit is 20, okay? So my rise is 40, okay? So you got to watch your units. My run is 1 unit, and it is only worth 1, okay? It's only going up 1, okay? So my rate of change is going to be 40 miles, right? Don't forget your units, over 1 hour. We cannot reduce that, so that is going to be my answer. Okay, let's look at line B. So line B is right here. Okay, here's line B. All right, and we are going to do our rise. So we're going to pick this point and this point. And my rise is 0. And my run is 1 unit, which is 1 hour. Okay, so we have 0 miles over 1 hour. We didn't have to rewrite that, but that's my answer. That's a horizontal line. So anytime you have a horizontal line, this rate of change is 0. Okay, it's like sitting in a light in a car. You're not moving forward, your distance not changing, but time changes. So your time has to change. That's why we keep moving to the right on a graph, okay? But you don't have to keep moving up because you don't have to move, but time does have to continue. All right, let's look at line E. So line E is over here on the right, and we're going to pick 2 points. So I'm going to go ahead and pick this point, and I got to follow it. Remember, you can't pick there, but I can pick here. Now, we also could pick here. I will tell you, in the other one I didn't do this, but the closer you pick your points, the less you have to simplify. Okay? So I'm going to count. I'm going to go, oops, let's make our rise and run lines. Okay, and I'm going down 3 units, and remember, every unit is down 20. Okay, so that means I am going a negative 60. Okay. Now, and then I ran 1 unit, which was 1 hour. Okay, and we don't have to simplify, so that is my answer. All right, so here's a rate of change, and this is in a table, so we don't have a graph. If you want to graph it, you can, but it's just as easy not to graph it. So whenever we have a table, if you remember from middle school, this is your x and this is your y, right? Always like that. So x will always be on the left, y will always be on the right. Now, our rate of change, another way we look at it is the change in y over the change in x. This little triangle here is what we call a delta in algebra or in math in general, and it just means change. Okay, so it's just talking about the change. So we want to find the change in y. So these are all my y values. Okay, now if I want to find the change in them, all I have to do is pick 2 of them. So I'm going to figure out what is the change between 70 and 40. Okay, now a lot of you guys can do that in your head, and you can say, well, you know what, it went up 70. But if you can't, or you don't like to do things in your head, you can subtract. Change is a subtraction. You're always subtracting, finding the difference of the 2 points. So my change is 70, okay? And it's miles. We got to use our units. All right, now our change in hours, okay, which is going to be the change in y here. Okay, the change in y is we are going to go, how much did it go from 2 to 4? So now, again, if you want, you can subtract, or you can say, oh, you know what, it went up 2. Okay? So it went up 2 hours. Now look at it, we can simplify it, so we need to. So it's 35 miles for every 1 hour. Okay? So if they went 70 miles, it would have taken them 2 hours. Okay, so rate of change, okay, you can always look at it, well, if I go longer, how far would I go? All right, here's the last one. The cost of the tickets to the amusement park is $19.50 for 1 ticket and $78 for 4 tickets. Okay, so a couple things. Money is usually always your y value, so that would make tickets my x value. Just how time is always x. Okay, so I'm going to go ahead and graph it. You don't have to graph these, but we're going to look at it the same way. So I'm going to go ahead and graph. So for 1 ticket, it was $19.50 right there. For 4 tickets, it was $78, which is right here. Okay, so this is my line. Okay, and I want to find the rate of change. So I'm going to we've done the first ones. We're going to rise, find the rise over the run. So my rise here, okay, is I went up, okay, all these. Now, it's not exact. It was $19.50 for $78, so you need to find the difference. So it's 78 minus $19.50, which is going to be $58.50. All right, now my run, okay, is units. Okay, also it's from 4 tickets to 1 ticket, which would be 3 tickets. So my rate of change is $58.50 for 3 tickets. Now if we're going to reduce that, it is going to be $19.50 for 1 ticket.